Assalamu alaikum. Ladies and gentlemen, thank you very much for having me here. As a scientist, I'm always intrigued with how human looks at mathematics, computational science, and artificial intelligence. One of the earliest things, and human has always wanted to automate things as much as possible. This is a old mechanisms, a computational mechanisms that was dated back to about 150 BC. It is a mechanism, and this is a reconstruction of it, to compute the periods, the times for athletes, the performs, and so forth. And over the period of times, human has created a lot of new form of machines, calculations, and so forth to help men to do all sorts of different things. Fast forward, only until the 18th century, or rather, we start to have mass automations. These are some of the examples, like the spinning journey, flying shuttles, and so forth, that we start to have mass automations. Fast forward to the 21st century, we now have robots to do almost everything. Making cars, assembling lines, constructions, and so forth. We have factories doing semiconductors and stuff like this. Xiaomi, as you would know. Many of these companies happening in China and all over the world. And we are now massively able to reduce the cost of each product because of all these automations. So much so that now we have the concepts of what we call the dark factory. A dark factory basically means that a factory without human being. You do not need to have human inside there, or rather, you do not need to switch on the lights because there's no human inside there. So we have come to a stage where automation right now has advanced so much. But of course, these are all automations at the factory levels and so forth. There are still a lot of tasks that we want it to be automated. One of them, and this is basically things will be like in the labs itself, where now you have labs that is fully automated. You do not need to actually do all the chemistry stuff of things, putting chemicals together, dangerous chemicals together, and so forth. You have machines that are able to generate out all the different data as fast as possible to generate your data for chemical process. But also the other things is that the daily life. Right, so one of the things that my wife actually always wanted me to do is that since you are in AI, can't you build robots like this that can actually help me to do my daily work? And this is request from, I believe that many women want to do this. But in fact, I think most of the men will want to do this because your wife will have been asking you to do all these things most of the time. So there are already automations like this all over the place. The question right now is that how can we bring down the cost enough to have this machine cheap enough to actually deploy in our house? We have automations already. We have automations from factories to cleanings, to cookings, and whatsoever. Of course, like I say again, it depends upon the manufacturing cost and so forth. And once the cost of these robots is able to come down, we will then able to deploy them all over the place. But the problem is this, is it able to do discovery? We are able to do automations, but are we able to do discovery? As a scientist, I'm actually a trained mathematician by training. We always want a way to find new things. As a scientist, it is not just about doing experiment, but to discover new phenomenon, new theory, and whatsoever. Is artificial intelligence able for us to do that? So I'm going to walk you through the path a little bit here. First of all, we look at the scoreboard. Artificial intelligence over the last couple of years has propelled, has improved, progressed tremendously, especially the last few years. If you look at the trajectory, it has progressed tremendously fast. And what we call predictive AI, things like predictive AI, you will see that, for example, like facial recognitions, airport, like Qatar Airport, right now you have a lot of automatic facial recognition. Singapore Airport, you could actually walk through the airport without having to show your passport, and so forth. So these are already all in productions, ready to use. Sports itself, we have changed sports altogether, right? You used to have referee counting number of punches. Now you have artificial intelligence to do all these things for you. I know that Qatar is big in soccer. Soccer right now is no more just having players running around the field chasing the balls. The entire planning is all about data. It's about artificial intelligence planning the strategy of the games, and so forth. Of course, the application of the artificial intelligence goes to many things. One of them is in the areas of healthcare. We are seeing more and more technologies being approved by FDA, right? From image recognitions to diagnostics to all sorts of things. There is now uses artificial intelligence in one way or another. And many of you, and over the last couple of years, what is exciting is about generative AI. Generative AI is not just about ChatGPT, by the way. Many of us has mistaken that generative AI is just ChatGPT. Generative AI is about having all these data from a mathematical perspective, put them into a statistical distribution, and then able to sample and generate out informations, interesting informations. And this is, one of them is, of course, many of you will have seen videos like this. All these are generated by artificial intelligence. Runway, Midjourney, Kimi, and many other different types of applications over the years. At the moment right now, we are able to generate tens over minutes of videos using artificial intelligence before it becomes incoherent. So I believe that somewhere in the future, we will be able to generate hours of videos using such a technology. The ideas of using this is extremely simple. As a physicist, as a mathematician, the whole idea is that they borrow the ideas from physics and then uses the concept of physics to generate out the artificial intelligence so that you can actually generate out all those interesting images and videos. Now, using the ideas of this generative AI, University of Osaka has done a very interesting about a couple of years ago. What they do is that they use the images, the fMRI images. Using those images, they are able to use the generative AI to produce the images that is probably seen by the patients. So, Singapore universities and Chinese University of Hong Kong take one step forward and produce a videos itself. Feeding the patient with videos, as you can see over there, is a ground truth. And what it does is a reconstructed videos of what they think the patient is seeing inside his or her brain. So basically, you think of it is actually some form of mind reading using fMRI scan. So there's a lot of new technology coming out, new algorithms and so forth. And one of the use case for this is in terms of using for mental patients. As you will know, that many of these mental patients, we do not know how the mental patient actually thinks. So if we could use the technology in such a way that we could look at MRI scans, we could then able to tell us that what the mental patient is actually seeing inside his or her brain. It will also be used for patients like this, where this patient has able to speak over after 18 years. Now, many of you will have very familiar with ChatGPT, right? But ChatGPT is actually part of what we call the large language models. Language models, natural language processing has been around for a long time. There are many models, as you could see over here, GPT-4, Llama, and whatsoever. The basic ideas of the language models become very pervasive because of a paper that was published in 2017. It's called, 2015. It's called Attention is All You Need. And then subsequently, Google's produced the Transformer. The Transformer basically is a neural network that have attention mechanisms. Now, remember that the language models, and this is something that's very important for us to know, the language models was designed to predict the next words or the next words, and subsequently the next phrase, the next sentence, the next paragraph, and whatsoever. It is used to predict that based on a probabilistic model. And that is the basic equations that is describing it. It's very important that you remember that. It wasn't designed to do understanding. It wasn't designed to do reasoning. It was designed simply to predict the next words. Now, however, the interesting thing is that what happened was that the community uses all the data in the world, as much data as possible, to train the models. And there was this interesting phenomenon that called the grokkering, that we start to see emerging properties. Property that seems that the language models actually understands, actually perceive to reason. And I use the word very strongly, perceive, right? There are a lot of mathematical studies that we see some geometries and starts to see that all this language, all these words starts to have relationship with one another, and so forth. Now, the good thing is that mathematically, we have shown that the language models is able to solve downstream problem. Don't worry about this. As a mathematician, I always tend to look at the mathematical problem, but the whole idea is that we have proven mathematically that it can solve certain downstream problems. So the language models itself has shown that it can pass financial examination. It's been used in banks, Goldman Sachs, and many other places, as you could see, over the exhibition hall and so forth. And there are also things like fewer false alarm, JP Morgans, and things that use for anti-money laundering efforts and stuff like this. And also used for stock outperform stock funds and so forth. But one of the things we must understand, and very important thing, is that the language models will hallucinate no matter what you do, because it is designed that way. It is designed as a probabilistic model. So for whatever people, marketing people, whatever, will tell you that we have solved the hallucination problems, whatever, that is not true. If you continue on to use the technology as I described over here, the transformer model, it will hallucinate. In fact, it's been proven mathematically that it will hallucinate no matter what it is. However, although it can hallucinate, we still can use it for many, many things, right? The other things is that we know that the language models, the transformer models, cannot do discovery. Experiments have shown that. We do not know yet. We do not know why. We only know that in experiment, we know that the language models, as it is right now, cannot do discovery. However, the idea of the language models or the foundation models had taken so much so that there are many other applications that revolve around it. If we can describe everything through tokens, through language, we can do some very interesting things. So one of them is, needless to say, in the medical space. So if we can code medical information, genomics, genes, whatever, as a language, we can build biological models that is based on what we call the biological foundation models. It can do extremely very interesting things. There are also robotics models, right? As you could see, as we know, robots is extremely challenging. To train a robot is extremely challenging. You may think that as a human, when we turn a knob, it's easy. For a robot to turn a knob, it takes a very, very complex computation to do that. Thus, we have to find a way of shortcutting it by using a foundation models to train the robots. So in Nvidia, we actually built something called the GROOT. And for those who are interested, can actually talk to me or my colleagues about this technology where we can use it for robotics training. The other things is the area of agents. You hear many of the talks about agents and whatsoever. Very importantly is that the last two things. Agent is able to do decision making and able to do action. Remember that the research of agent has been going on for a long time, even before artificial intelligence. There was all sorts of other agents, technologies, and whatsoever. But now you have language models, you have reinforcement learning, and many other technology that allow us to do this thing in a more efficient manner. Right, so these are the examples, as you could see, can use for
Play me the final song from the movie
as assistance, right? Perplexity. And then I think many of you would have already used it in one way or another, helping you to book restaurants, helping you to do many other things and whatsoever. Another project is by Google's Project
I'm here with
Astra.
the latest research prototype of Project Astra, and we're going to see how it can help me fix my bike. Hey, go online and look for a user's manual for a Huffy mountain bike.
I have found a user manual for you. What would you like to know about it?
Okay, cool. Now scroll until you find the section about the brakes.
Sure thing. Looking for that page now.
I think I stripped this screw. Can you go on YouTube and find a video for how to fix that?
Of course. I'm opening YouTube now.
Due to lack of time, I'm going to cut short the videos, but for those who are interested, I will share that with you.
Oh, nice.
But also the other thing, just to switch gear a little bit here. One of the very important technology that we actually, in fact, some of us has actually forgotten. Fortunately, I think the earlier speaker has brought up is AlphaGo. AlphaGo is a very extremely important technology that developed by DeepMind. Again, reinforcement learning has been around for a long time. The idea behind reinforcement learning is a penalty and reward algorithms. It's just like how we learn to walk. When we make a mistake, we get a penalty. When we get it right, we get a reward. The question is that, can we actually encode that into algorithms? And algorithms look extremely simple over here, but it's extremely difficult to implement. Over the years, we have done many things, and this is examples of a robot that's able to put the red pig into the hole by itself. The robot wasn't taught how to put it in. The robot was just asked to put it in. And this is a very old examples of it. This has been training for, of course, this is accelerated images, videos. And you could see that it trains for a long time before it's able to put the red pig into the hole. But what is important here is that these algorithms learn by itself. It learns to do certain things by itself. And in fact, in Alpha 0 was being designed in such a way that it does not take on human games. It plays against itself, it learns itself, and so forth. Now, with the vast amount of computation that we have, we can then able to do things like this, where we have robotics that are able to train all these things together. Right? So I'm going to accelerate the talk a bit over here due to the lack of time. And these allow people to build things like AlphaGos and so forth. Now, with this technology, now we can able to build automatic code programming and so forth. And also things like no code. With the advance of technology, GPUs, titanium, ironwood, whatever, we have managed to improve the performance tremendously. That's actually dropped the price of all these ChatGPTs and stuff like this. In fact, so much so that the price of technology has come down. Now, there are many other things like, now algorithms, we are able to design algorithms that evolve, learn by itself and evolve. We're also able to do basically thinking of robots building robots, that's able to AI building AI, robots building robots itself, right? And so forth. And in fact, with the aid of quantum technology, now we are looking at quantum technology together with artificial intelligence and so forth. So we are doing things like large language models with quantum technology. Now, as you will know, that one of the things about language models is that it cannot. So one of the things that we want to do is what we call the world model. The world model is the way that we actually, how our mind actually thinks. We actually create a world model inside our mind. We simulate it before we do anything. The thing is that the mathematicians and the scientists has managed to develop the mathematical models behind it. And we are now able to do things like, for example, like what Li Feifei has done. This is a world model. Basically, by using certain very simple prompt, you have to create the models. And that models allow us to do training for the robots, for many other things. There are many other robots around, and there are many other models, things like this, where you have the first frame and the last frame, and your computer will generate all the things that is in between. So now we are able to produce scientists. Scientists attempt to build scientists. Sorry, let me just get on this. Build scientists towards a fully automated scientist, right? And there are many experiments going on right now. In fact, there are many models going on right now. And in fact, together with things like graph theory, together like with all these neurosymbolics technology, we are able to move even further and stuff like this. So there are projects like this, for example, the Zero projects, and some other co-scientist projects, and other stuff like this, like Cosmos, and so forth. So we are seeing, with all these technologies coming up together, right, we are now beginning to see that we are able to truly approach not so much of an AGI, but a technology that allows us to build agents that are able to do discovery. So hopefully, one day, we were able to build things like Jarvis and so forth. So with that, I end my presentation. So thank you very much.